Hello, my name is Seungwan. I'm presenting AI-Augmented psychotherapy through a hierarchical attention mechanism. This is work done with Hoyoung, Choi, and Kyungsik at Hoyoung University. Our slides include research background, model development, experiments, and conclusion. Our research background is increasing the need for psychological support. According to the survey results from Pew Research, teenagers and adults are experiencing stress, anxiety, and depression. Psychological health is one of the biggest social problems in modern society. Therefore, it is becoming important to diagnose these mental illnesses early on. According to the clinical psychology approach, there are self-report surveys and projective drawing tests for checking mental illnesses, such as stress, anxiety, depression, and so on. As stress, for example, a self-report survey can evaluate one's stress state by answering several questions as shown in the figure on the left. And the projective drawing test is one of the psychological tests in art therapy. The test is conducted through analysis of drawn image and post-drawing inquiry of subject, as shown in the figure on the right. In this research, we are focusing on the projective drawing test. Unlike a self-report survey, the projective drawing test has a characteristic that allows the subject to express his or her status and feeling that is sometimes hard to express in words. Therefore, this test methodology is effective for psychologically vulnerable individuals without using language like children. However, the projective drawing test also has a weakness in subjectivity. Since subjects have their own experiences and values, drawn images can be subjective. Because of this reason, art psychotherapists often struggle to make objective judgments during diagnosis and depend on their empirical judgments. According to previous studies, the need for data-driven approach has been raised for objectivity. We collected PITR test data, which is one of the projective drawing test methodology, can measure stress status. The PITR test was conducted under the guidance of a therapist, and the subject imagined a person in the rain and sketched it. And our therapist asked 10 post-drawing inquiries, which are called PDIs in short, and the subject write their answers to 10 PDIs. For data labeling, we recruited 10 art psychotherapists, and we investigated the therapist's diagnostic processes and identified the following 4 steps. At the first step, the therapist identifies stress factors and copying ability resources in the drawn images. At the second step, the therapist identified keywords and evaluated the keywords consistency with the drawn images, and then evaluated the consistency between individual PDI answer sentences and with drawn images. In the third step, therapists identify comprehensive consistency by looking at all the answers and drawn images together. And lastly, therapists make their decision and label the data for classification, stressed or not stressed. And this slide is for our AI design. We figured out the challenges of the decision-making of our psychotherapists in diagnosing the PITR test and the requirements of objectivity. And we also found that to increase acceptance of AI models, therapists wanted to reflect their workflow to AI models instead of the end-to-end black box models. Therefore, we aim to reflect on the art psychotherapist diagnostic processes and characteristics. And we propose a stress classification model, M2C. M2C stands for multi-modal two-stage quotation. In stage 1 quotation, M2C learns the associations between one drawn image and word tokens in each PDI answer. In stage 2 quotation, M2C learns the associations between drone images and PDI sentences. In this slide, let me explain the notation of our dataset and the input-output of our model. Uppercase D refers to a set of drone images consisting of n drone images. Uppercase A refers to a set of the PDI answers of the entire dataset, and it consists of n PDI answer sentences. Lowercase a sub I consists of answers for 10 PDIs. Therefore, our model, M2C, receives one drone image and 10 PDI answers together at one time and classifies stressed or not stressed. Let me explain the overview of our model. First, our model includes drone images and PDI answers, respectively. Second, our model learns the consistency of the associations between word tokens and drone image and individual sentences with drone images through these multimodal two-stage co-attention. And finally, classification is conducted. Our co-attention mechanism is shown in the box on the right. From now, I will explain the detailed process of our model. We encode the drone images using pre-trained VGG11 and PDI answers using pre-trained BERT. The output values of these encoding stages are entered into the input of the stage 1 co-attention model. The goal of our stage 1 co-attention is to learn individual consistency between drone images and word tokens in a PDI answer sentence. To end this, first we construct an affinity matrix to obtain two modalities hidden layers with cross operation. By using the hidden layers, we could obtain the attention probabilities for each modality. And we obtain the final feature vectors at stage 1 by multiplying the encoded results of each modality by the attention probabilities. The goal of our stage 2 co-attention is to learn comprehensive consistency between drone images and 10 PDI answer sentences. To end this, we construct an affinity matrix similar to stage 1 co-attention. To construct this affinity matrix, the encoded feature vectors which are obtained from the co-attention stage 1 are used. And we could obtain two modalities hidden layers which are from cross operation using the affinity matrix. As in stage 1, we could obtain the final feature vectors in stage 2 co-attention. And lastly, our model classifies the stress level of the PITR text. As shown in table 1, our model M2C outperformed other single and multimodal models, and parallel co-attention was the second highest. These results demonstrate the effectiveness of the hierarchical co-attention technique. And especially our two-stage co-attention was more appropriate for learning the characteristics of our data. This slide shows our qualitative results. Each figure shows one drone image and PDI answer sentence with the highest weight in the prediction stage of M2C. Let's look at case A. Ground truth of case A is not stressed. Our model M2C also predicted it as not stressed and visualized an appropriate co-attention map, as you can see, with a text description of the drone image. Red color means high attention weight and green color means low. And ground truth of case B is stressed, and our model also predicted it as stressed. According to the context of the subject answer, it can be seen that the person in the image does not have an umbrella, which is one of the copying ability resources. Additionally, considering the feature of rain and the facial expression of the person in the journal image, we can see that our model predicted it well. This slide shows another qualitative result. Let's see figure 5. In the case, ground truth is not stressed, and prediction of our model was also not stressed. But the prediction of Electra was stressed. Figure 5 shows that it is ambiguous to judge stress levels with only text, and there is an inconsistency between the image and PTI answers or between the individual PTI answers. These characteristics are similar to therapist decision-making processes. By reflecting on the decision-making process, MTC could supplement the limit of the text model. After the experiments and evaluation studies, we found our model can be effective in a stress diagnosis. As I explained, our data has one-to-many pairs of images and text, and subjectivity and inconsistency characteristics. Therefore, it was necessary to reflect on the therapist's decision-making process to achieve good classification performance and achieve good acceptance of the model. We showed its effectiveness through quantitative and qualitative evaluation studies. We believe our research methodology can be extended to our domains. And in the end, beyond the model-centered evaluation, we are planning to conduct a user study to evaluate the user perception of model to show that human-centered AI design can be effective in user perception of AI. Okay, thank you for listening.